Okay, today we're going to look at our notes. Y equals IV plus CROCx. The IV stands for initial value, and CROC stands for constant rate of change. Okay, the first problem, we are told that Dog Smart's basic fee is $12 to groom your dog plus 20 cents per pound. So the basic fee is $12 to groom your dog plus 20 cents per pound. The first thing I want to do is write an equation for this. So let's think about it. Their fee to groom your dog, which they call G, is $12 plus 20 cents per pound. So $12, that's just a one-time thing, plus 20 cents per pound. So 0.20 P. And this is pretty tiny, so hopefully you can see it. So G equals 12 plus 0.20 P. Okay, then it wants to know which one's the independent variable. The independent variable is the X. Well, we didn't use an X today. Instead, we used a P. So the independent variable is going to be P, and P stands for number of pounds that the dog weighs. The dependent variable is the Y, but today we didn't use a Y, today we used a G. And G stands for the fee to groom our dog. Okay, the initial value is what we have to start paying no matter what. And we have to pay $12 just to groom the dog. Doesn't matter what they pay. And the constant rate of change is something we have to keep doing over and over and over and over again. Well, we have to pay 20 cents every single pound that the dog weighs. So that 20 cents would be the constant rate of change. Okay, now we're given a problem to do. It says, evaluate the equation for a dog that weighs 50 pounds. So if the dog weighs 50 pounds, where would I put the 50? That's right, I'm going to put 50 where the P is. So it would be 12 plus 0.20, which I could just write as 0.2, times 50. Okay, I'm going to go ahead and grab my calculator, and I'm going to enter it in just like how I wrote it. 12 plus 0.2 or 0.20, it doesn't matter, parentheses, 50. And I get 22. So that's how much money I have to pay for a dog that weighs 50 pounds. So $22 is the amount we have to pay for our 50-pound dog. Okay, let's try some more. The Miss Texas might win the pageant. She has 400 points right now, but the judges must deduct 15 points each time she is rude to another contestant. Okay, so she might win. She has 400 points right now, but the judges must deduct 15 points each time she's rude. Okay, so I want to try to write an equation for this, and we're going to be talking about how many points she has versus how many times she's rude to somebody. Okay, so they said to use win. So her winning number of points, she starts off with 400 points. And then if you have to deduct 15 points every time she's rude to somebody, then it's minus 15, and they said to use a C. Okay, so the independent variable is the X, but we didn't use X, we used C. So our independent variable is C, and C talks about the number of times she's rude to another contestant. So number of times she's rude to another contestant. And I'll just put number of times she's rude. Okay, the dependent variable is the Y, but I didn't use a Y. Instead, I used a W. Well, W stands for how many points she has. And I'm just going to write that down, number of points. So if she has the highest number of points, then she can win, which is why they said to use a W. Okay, initial value. What did she start off with? She starts off with 400 points. And then the constant rate of change, what's happening over and over and over again? She can lose 15 points every time she's rude to somebody. So that's a minus 15. Okay, now let's try our problem. It says Miss Texas is rude 5 times. So where would I put that 5? I would put the 5 in the C, because C stands for how many times she's rude. So it would be 400 minus 15 times 5. Okay, let's get out the calculator. 400 minus 15 times 5. And that's 325 points that she currently has. Okay. Next problem. Bradley. He borrows $450 from his parents for a guitar. He must pay them back at a rate of $15 a week. Okay, so we're talking about how much he borrows, B, from his parents, and he must pay them back at a weekly rate of $15. Okay, so B, how much he owes them. If you borrow $450 from your parents, is that a positive number or is that a negative number? If you borrow $450, is that money you have in your pocket or money you owe? Well, if it's money you owe, it needs to be a negative $450. And then if he's paying them back at a rate of $15 a week, that means he's making $15 every single week. So that's a positive to our name. So it's plus 15W. So the 450 is a negative number because that's how much we owe. But this $15 that we're making, that's money in our pocket. And we'll use that money to pay back what we owe, but it's still positive money to us. Okay, so independent variable. Typically it's the X, but instead of X, this time it's a W. And W stands for the number of weeks. You're paying them back $15 every week. Okay, the dependent variable is typically the Y, but this time it's a B. And B stands for how much we borrowed. So the amount borrowed. It's how much he owes. Okay, the initial value. That's negative $450. That's what we borrowed. That's not our money, so we think of it as a negative because we owe it. And then our constant rate of change, what's happening over and over and over? Well, we're paying back $15 every week. So 15 is the constant rate of change. And so that's money that is ours until we give it up. And so that's why we think of it as a positive 15. Okay, now let's try the question. The question says, 6 weeks have passed. What does he still owe? Okay, if 6 weeks have passed, where would I put the 6? That's right, in the W. So I'm going to calculate negative 450 plus 15 times 6. Okay, and I'm going to enter that in my calculator. Negative 450 plus 15 times 6. And I get a negative $360. So that's how much he owes. But when I write it, I don't need to write it with the negative. Since it says how much does he owe, well, $360 is what he owes. And so we know if he owes that money, then it's not really a positive amount in his pocket. It's a negative amount, but we don't have to write it like a negative. Okay. The next problem. My Mr. Coffee holds 3 quarts of water. Each time someone has a mug of coffee, 1 cup is used. And then it says, hint, change 3 quarts to cups. Okay, first of all, does anybody know how many cups are in a quart? If you didn't know, you could Google it, but I'm just going to tell you off to the side here. There are 4 cups in 1 quart. So since the hint was to change 3 quarts to cups, how many cups would 3 quarts be? There's 4 cups in every quart. 3 quarts would be 12 cups. So I'm just going to make this at 12 cups. Okay, so the Mr. Coffee holds 12 cups of water. Each time someone has a mug of coffee, 1 cup is used. All right, so let's try to write an equation. So I'm going to use C equals, we start off with 12 cups. That's how much the Mr. Coffee will hold, is 12 cups. And then every time someone makes a cup of coffee, they're using a cup. So minus 1 for every mug that someone makes, which we use an M. So the Mr. Coffee starts off holding 12 cups in it, and then people use 1 cup for every mug they make, so that's why we have to subtract. All right, independent variable, what do you think? That's right, it's M, typically the X, but in this problem we used an M, and that stands for the number of mugs that people have used. Our dependent variable, the Y, but this time it's not a Y, it's a C, stands for how many cups our Mr. Coffee has. I'll just put how many cups total. Okay, the initial value. How much does our Mr. Coffee hold at the beginning? That's right, it holds 12 cups. The constant rate of change, what happens over and over and over again? Well, over and over and over again, they use 1 cup of coffee for every mug, and that is a minus 1, because if you're using the coffee, you have to deduct it. Okay, and then the problem. 8 people have had a mug of coffee. So if 8 people have had a mug, then we would put an 8 where the M is. And this one's easy. I don't even need to grab the calculator for this, but I will. 12 minus 1 times 8, and you get 4. So you have 4 cups left. You start with 12. 8 people make coffee. They use a cup each, so there's 4 cups left. Now, if you ever find that your answer doesn't make sense, then you probably wrote your equation wrong. So kind of think about your answers as you work the problems. If they don't make sense to you, then you probably did something wrong with the equation. Okay, so tomorrow when you come to class, you are going to do these bottom 2 problems as your warm-up when you first come in. Okay, so that's it for today. But you can either try them now on your own, or you can wait until tomorrow morning or tomorrow afternoon, whenever I have you, and you can do them as your warm-up problem. So I'll let you decide what you want to do with that. And thank you very much. Little smiley face.